and a very warm welcome to our Siemens conference session all around energy efficiency. Our Siemens KNX portfolio is the smart way to create connected buildings, and our products are based on the international KNX standard for home and building control. They are interoperable with all certified KNX devices on the market and can be integrated into different building automation systems for all the flexibility you need to meet the requirements of modern buildings. In this presentation, we'd like to provide you with all information you need when it comes to a KNX-based room temperature control to achieve an optimum energy efficiency. We aim to provide you with the smart way to create connected buildings, the right temperature, the right lighting, and transparent operating data. Creating perfect indoor conditions needs a portfolio that combines flexibility with easy installation and comprehensive functionality. We offer you the full range of all products you need to create a high-performance KNX system across all trades. Today, we have our expert Olaf Krüger with us, who will provide you with all information you need around KNX-based room temperature control according to demand.
Yes, thank you, Anna, for this nice introduction. My name is Olaf Krüger, and as a product manager at Siemens, I'm responsible for a large KNX-based portfolio. And I would like to go a little bit deeper into this topic of energy efficiency with KNX. And we'll also show this later with a specific application example. Yes, KNX as an open standard protocol for commercial and non-commercial building automation can save up to 60% energy. And these possibilities are well known, and they are more important than ever in this current situation with energy crisis and climate changes. It integrates all building functions in one intelligent system. It therefore not only guarantees comfort and safety in a room or in a building, it also reduces costs and above all, increases energy efficiency. The base is consistent products coordinated with each other. They make optimized energy consumption in building possible. And Siemens offers such a KNX portfolio as Anna already said. It includes all important traits such as heating, ventilation, air conditioning, lighting, and solar protection. KNX control devices are the basis for building and room automation. They automatically close or open the solar protection and regulate the room climate. Presence detectors, light sensors, switch the lighting on and off and control the illumination level as required depending on the amount of daylight. The room temperature controller for heating, cooling, and ventilation guarantees an optimal room climate. Corresponding sensors provides the appropriate room values for temperature, humidity, CO2 content, or air quality. All room functions can be operated manually via control units such as push button or a room control panel. And thanks to KNX-based room automation, all these devices, all these systems work in a perfect harmony to achieve maximum energy efficiency. In this presentation, we'll use the application example of a KNX-based intelligent individual room temperature control to explain how heating energy can be saved with the innovative KNX devices from Siemens. The KNX room temperature controllers regulate exactly to the specific set point temperature. The benefit here is a central set point adjustment and operating mode setting in combination with a presence detector or an access control system. The operating mode can be controlled according to use, thereby achieving a reduction in energy consumption. If window contacts are used, the room temperature control can automatically switch to protection mode as long as the window is open, so that the control only becomes active again when the temperature falls below a frost protection temperature. At night, the temperature control can be automatically switched to energy saving mode via central command, for example, from a building management station or a time scheduler. And the further saving potential is in the communication of the heating or cooling demands to the control of a primary system in order to adjust the flow temperature. Which components are needed for temperature control? A room thermostat or a room control unit is always required in a room. The beautifully designed multifunctional touch control TC5 is used for this purpose. This has 5-inch color touch display and is available in black or white. It can be installed horizontally or vertically. The display changes accordingly. The touch control has an internal room temperature sensor. This is included in the temperature detection in this application. There's an LED colored light strip as an orientation light or for signaling alarms. And this display is used in the application to indicate the heating mode, a very important gimmick. The desired set point temperature is set via the room control unit, or the room operating mode is changed. In addition, the current room temperature is displayed, which can also be detected in the room control unit. Compared to a thermostat, a room control unit has the advantage that in a cross-functional system with KNX, all functions in the room can be controlled by one device. Various room sensors values can be displayed at the same time. In addition, to the room temperature control described here, this includes functions such as switching, dimming, tunable light, forward light control, or human centering lighting. This includes the control of solar protection or HVAC applications such as floor heating, ventilation systems, VRV, VRF applications are realizable, or also a scene control, various logic functions, timer functions, alarm handling, and much more. The heart of this room temperature control is the thermal drive actuator. There are two models for different mounting variants to choose from. The N605D41 thermal drive actuator is available as a DIN rail mounted device for installation on a DIN rail in an electrical distribution board. This is a 6-volt thermal drive actuator for noiseless control of the thermal actuators of up to 6 heating or cooling circuits. The N605D41 also has a direct operating level on the front of the unit, and with this, the valves can be opened and closed manually, and the installation can be checked. Furthermore, the N605D41 indicates a mains voltage failure, overcurrent or short circuit error via 6 error LEDs on the front of the unit. And the RL605D23 thermal drive actuator is available as a compact modular device for centralized installation in the control module box AP118 or in a room control box AP641. It makes it possible to install the actuators on the wall, parallel bed ducts, in installation columns, in raised floors, or above suspended ceiling. The modular RL605D23 is a 2-volt actuator for noiseless control of the thermal actuators of up to heating or cooling circuits. Both actuator variants can be used to control both de-energized closed and de-energized open valve drives. Both actuators are basically identical in their application and are considered eagerly in the following application description. In contrast to the N605D41, the modular thermal drive actuator RL605D23 has no direct operating level or error display on the unit. Why do the thermal drive actuator form the core of the following application description? In addition to their core function of controlling the thermal actuators, the thermal drive actuator have room temperature controllers that match the number of channels. Their control value outputs can be linked directly internally to the channels for valve control. It means that communication via the KNX bus using group addresses is not unnecessary. The application includes various safety and override functions for service and maintenance. To protect against calcification, the valves can be flashed. Furthermore, various information about the heating or cooling demand can be transmitted to a primary system, and ultimately serves to save energy. This is important. The calculation module offers a very interesting possibility. Different temperature values, which are detected at different points in the room, can be weighted individually. As a result, a very representative measured value is used as the actual temperature in the room temperature controller. This value can also be transferred directly internally. The temperature should be lowered for energy efficient room temperature control when rooms are not occupied. This required a presence detector in the room. We use a presence detector white from the right portfolio of ceiling mounted multi-sensors for this purpose. Motion and presence detection are available with all device variants. And at the same time, temperature detection is also used in the application. Since this measurement on the ceiling is not always optimal, depending on the technical conditions, the detected temperature is later weighted with the temperature detection from the room control unit via the calculation module in the German drive actuator. In order to lower the room temperature to a minimum set point when the windows are open so that only protective operation is effective, the status of windows is evaluated via window contacts. Status of the window contacts is detected via potential free KNX binary inputs and transmitted to the KNX bus. Depending on the installation and mounting options, general mounted devices or flash mounted devices, for example, push button interfaces, are used here. The schematic structure of the room temperature control is shown below. The central component is a controller. A PI controller determines a continuously control value from various input variables. And this control value is converted into a binary signal on or off via pulse width modulation. The German drive actuator is then energized or de-energized via a semiconductor output, thus opening or closing the valve. And this process and the control loop occur entirely in the German drive actuator. The controller requires the actual temperature in the room as input variables. It also needs a set point temperature. This is the default value to switch controls to be performed, and the room operating mode can be set. A distinction is made between the different room operating modes: comfort mode, pre-comfort mode or standby mode, energy saving mode or night mode, and protection mode. These are set depending on the room usage. Each room operating mode is assigned a suitable set point temperature during the ETS commissioning. The room control unit supplies these three input variables. Presence detection is required for switching to the room operating mode comfort mode. Presence detector provides this information. Since the presence detector is also equipped with a temperature sensor, this measured variable is also considered. To detect the actual temperature as accurately as possible, several measuring points in the room should be evaluated and the values of the different measuring points rated accordingly. To graphs detecting the actual temperature via room control unit near the door can be inappropriate. The lighting or also heated or cooled ceilings can influence the measured value of a presence detector on the ceiling. Using the calculator module in the German drive actuator, both measured values can be weighted in a ratio of, for example, 50 to 50%, and the results transferred to the controller. To switch the room operating mode protection mode when the windows are open, you need the window status. In principle, evaluating the presence or the window status is optional. This illustration shows a typical room installation for controlling the thermal actuators in a radiator heating system. This is the basis for the following project commissioning. In this example, an office room is heated. The KNX DIN rail devices, such as system devices for the KNX power supply, KNX routers, KNX interfaces, line couplers, gateways, etc., and the corresponding actuators, controllers, and input modules for further functionalities are located in an electrical installation distributor, which is installed, for example, in a plant room. The room control unit TC5 is usually located in the entrance area of the room, next to the door. The presence detector right is mounted on the ceiling in a good detection area of the workstation for the actual thermal drive actuator. The modular version RL605D23 is used in this example. This can be installed with the control module box AP118, which is available as an accessory for decentralized installation in a day-to trunking under the window. The thermal drive actuator is in the immediate vicinity of the thermal actuator. There is a short wiring pad for the load side connection. The individual components communicate via the green bus line. In summary, an overview for all KNX products used with their order number, picture dimensions, and product designation. For commissioning with the ETS configuration software, the ETS database entry and an application program description describing the functions, the parameter settings, the communication objects are required for the corresponding devices. At the same time, technical information is required for installation, assembly, and wiring. These documents can be found for each product in the Siemens Gamma product database. You can start the Gamma product database with the following QR code. You can select product by clicking in the chapter. All products are categorized according to their application and characteristics, or you can find the products you are looking for via the order number MLFB or via a short text. In this way, the modular thermal drive actuator RL605D23 used in the application will be found. The ATS database entry is loaded here. Usually, the Siemens ATS database entries are already available for selection in the ETS online catalog and only needed to be inserted to the project. The corresponding application description for ETS parameterization can be found here. The operating and installation instruction, the technical product information can be opened here. Finally, the group addresses used and thus linked data points are to be shown. Via the group address 0/0/1, the room operating mode set on the TC5 room control unit is transferred to the controller of the thermal drive actuator. The actual temperature measured at the TC5 room control unit is transferred to the calculator of the thermal drive actuator via group address 0.0.2. The set point set on the TC5 room control unit is transferred to the thermal drive actuator controller via group address 0/0/4. Now they have a complete overview to how to link the data points in a demand-based heating application with Siemens components. And that brings me to the end of this presentation. And I hope this technical application description can help you to save energy and inspire you to use the KNX products from Siemens in your future projects. Thank you for your attention, and please do not hesitate to ask your questions. Thank you.